Hello everyone. Welcome to our channel. In our previous videos, we explored the history of natural numbers, fractions, negative numbers, zero, rational numbers, and irrational numbers. It took mathematicians many centuries to build what we now call the real number system. Natural numbers, together with the later discovery of zero, became the whole numbers. Adding negative whole numbers gave us the integers. Integers combined with fractions formed the rational numbers. Finally, when irrational numbers were recognized and understood, all of these together created the real number system we use today. Today, we continue our journey along the roadmap of mathematical discoveries. As we explore the fascinating history of imaginary numbers. Here is the outline for this video. The early challenges. Scipione del Ferro and Gerolamo Cardano, 1500s. Rafael Bombelli, 1526 to 1572. The 17th to 18th centuries. The 18th to 19th centuries, Euler and Gauss. The modern perspective. Summary. What is an imaginary number? By definition, an imaginary number is any real number multiplied by the imaginary unit I, where I is defined by the property that the square of I is equal to -1. The powers of the imaginary unit I are cyclic as shown in the screen. The square of an imaginary number b, I, is therefore negative b square. For example, 8i is an imaginary number, and its square is -64. Interestingly, the number 0 is considered both real and imaginary. Imaginary numbers may sound impossible. They involve the square root of negative numbers, like the square root of -1. For a long time, negative square roots were considered impossible or meaningless. For centuries, mathematicians struggled with them when they were solving cubic equations. They tried to understand these square roots of negative numbers. The Greek mathematician and engineer, Herod of Alexandria, is noted as the first to present a calculation involving the square root of a negative number. Scipione del Ferro, an Italian mathematician, first discovered a method to solve the depressed cubic equation. In the 1500s, Italian mathematicians like Cardano encountered square roots of negative numbers when they were solving the cubic equations. They didn't know how to interpret these square roots of negative numbers, so they called them imaginary. In 1545, only Cardano published them in Ars Magna. At the time, imaginary numbers, and even negative numbers, were poorly understood. Many mathematicians viewed them as fictitious or useless, much like zero had once been. Rafael Bombelli was the first to handle imaginary numbers systematically. He created rules for adding, subtracting, multiplying, and dividing numbers like a plus b, I. He realized that imaginary numbers could be used as intermediate steps to solve cubic equations, even if the final answer looks strange. Many mathematicians were slow to adopt imaginary numbers. Even René Descartes, 1596 to 1650, who introduced the term imaginary in law geometry, used it in a dismissive and derogatory way. As a result, the use of imaginary numbers was not widely accepted for quite some time. Mathematicians slowly accepted them as algebraic tools, but many still thought they were purely abstract. Leonhard Euler, 1707 to 1783, introduced the notation I for the square root of -1 and explored complex numbers in equations. Carl Friedrich Gauss, 1777 to 1855, rigorously defined complex numbers as points in the complex plane, giving them geometric meaning. Imaginary numbers are now well understood as part of the complex numbers, written in the form a plus b, I, where both a and b are real numbers. Numbers like 5, I, are no longer considered impossible, they are essential for solving real-world problems. Today, imaginary and complex numbers play a fundamental role in algebra, calculus, signal processing, quantum physics, and electrical engineering. In summary, imaginary numbers were initially controversial because they involved taking the square root of a negative number. From Cardano to Bombelli, mathematicians began using them to solve real mathematical problems. Euler introduced the modern notation I, and Gauss provided a geometric interpretation through the complex plane. Today, imaginary numbers are indispensable in both pure and applied mathematics. It is time to end our topic. Next, we shall talk the history of both real number system and complex number system. Okay, don't forget to like and subscribe. See you next time.